Hi, welcome to Craft Crew Math. My name's Isaac Kraft. I'm the dad of the Craft Crew. My job during the daytime is teaching 6th grade math at Youngstown International School of Seoul, so I decided to just go ahead and post the videos that I make for my classes onto the channel. If you're here and you need help with 6th grade math topics, I hope you enjoy. Here's the video. Welcome to Math with Mr. Kraft, where I review the things that I've been going over in my math class with my students. This is a recent practice test that we just took, and if you are one of my students, then you know this because you just did it. The concepts we're going over here are the sort of introduction to algebraic ideas, variables and terms and constants and coefficients, and how do you write a variable expression from a word problem? How do you evaluate a variable expression if you're given the variable? How do you work with numbers when you don't actually know what the number is? These are all the kinds of things that we're going over in this video today. So if you want help with that, buckle up. Here we go. So identify the terms, coefficients, and constants in the expression 15x plus 3. So a tip for knowing what a term is, terms are always the things separated by the plus sign or the minus sign. So here we have a plus sign, so I just put a little box around those things separated by the plus sign. So my terms here are 15x and 3. Coefficients. For coefficients, I always remember the prefix there, co, which means, you know, like with. Reminds me that coefficients are numbers that go with a variable. So if I look at my expression, I have one number that's by itself, and I have one number that's with a variable. So my coefficient here is 15. And constants are numbers that they stay the same. They don't have a variable with them. Variable, the word variable comes from the word vary, which means, you know, change. And so constant is the sort of opposite of varying. So it's the one that doesn't have a variable. So that's 3. All right, so that's number 1. Number 2, a bit more complicated. Identify the terms, coefficients, and constants of q thirds plus 6 plus 9q. So again, so terms, the things separated by the plus sign, so I just kind of highlighted them there, so that would be q over 3, 6, and 9q. Coefficients, this one is a little bit more tricky, so remember it's the ones with the variable. So obviously 9 is a coefficient, it's with the variable, but the other one that is kind of harder to see is 1/3, which is the other coefficient. So if you look at this q over 3 there, you can imagine this as being 1q over 3, like how many q's are, you know, how many q's are right here? Well, there's just one. That's why it's 1q. If it were like 2 q's, it would say 2q over 3 or 3q over 3 or whatever. So there's no number in front of that q, so we can just go ahead and assume that it's a 1. So that's 1q over 3. So the number that's actually with the q there is this like 1/3, right? So the coefficient for that one, for that variable, is 1/3, even though it's kind of hard to see. And then the constant there by itself, the number 6. All right, so that was number 1 and number 2. Moving on. Number 3, which expression is equivalent to 6 times s times s times s times s? It's like a snake. 6. How many s's are there? So there's 1, 2, 3, 4, 5, 6 of the s's, so that's 6s, and all these are being multiplied together, and when we have a bunch of multiplication in a row, that is a power. So that's 6x to the 6th power. That would be this here. Okay, don't get fooled by this, right? Or just this. Okay. Make sure you remember how powers work. The 6th power, it goes with the s. It doesn't mean 6 times 6, so not this. And don't forget about the 6. The 6 stays there, so not that either, right? Moving on. When y equals 5, the value of y squared plus 5 is blank. So if y equals 5, that means, you know, like it's y squared. What is that doing there? That means it's y squared plus 5. So basically what I can do here to solve this is whenever it says, like, find the value, I'm just trying to find the answer for whatever variable it gave me. So basically I just kind of take out the y, and instead of y, now it tells me that y is 5. So instead of y, I'll just put in the 5. So that's 5 squared plus 5. 5 squared is 5 times 5 plus 5. So that's 25 plus 5. So 30 is the answer to this one. So 30. Okay, moving on. So it says playing time is added at the end of a soccer game to make up for stoppages. An expression for the length in minutes of a 90-minute soccer game with X minutes of stoppage time is 90 plus X. How long is a game with 4 minutes of stoppage time? So in this one, this is a very simple word problem for how to evaluate algebraic expressions with a very simple expression. So 90 plus X, and it tells us that basically it says here X minutes of stoppage time. So that means that X is the amount of stoppage time. So X equals stoppage time. And then it tells me that there are 4 minutes of stoppage time. So I know now that X equals 4. So instead of 90 plus X, what I'm actually doing is 90 plus 4. So it's just 94 is the answer. 94. Okay, don't overthink it. It is as simple as it seems like it is. Number 6, write the phrase as an expression. The product of a number C and 5. Okay, so now we're taking words and we're transforming them into math problems. So the word product is the key here. The word product, it tells us that we're multiplying. So it's going to be the multiplication of C and 5, so that would be C times 5, or the most mathematically correct way to write it would be 5C, would be the answer there. Okay, moving on from that. Number 7. Choose 2 ways to write the expression P minus 5 as a phrase. So we have 4 options here. I'm just going to write them all out as algebraic expressions, and then we're going to pick the ones that match P minus 5. A number P fewer than 5. So this one says fewer than, which does mean subtract, but fewer than also means flip the order around. Like if I think about like 6 fewer than 11, that would be 11 minus 6, not 6 minus 11. So this one would be 5 minus P. A number P decreased by 5, so decrease means subtract, so that would be P, and then I decrease it, so minus 5, so that would just be straight up minus 5. And then 5 decreased by P, so that would be, again, decreased is minus, and it stays in the same order, so 5 minus P. So not this one and not this one, so it must be this one and this one. But let's take a look at the last one anyway. 5 fewer than a number P. So again, fewer than, it means minus, and it means flip the order around. So in this one, P is going to be first and then minus 5. So that is going to be what we call it. We'll call it B and D. There are the answers. Okay, number 8. So this one is kind of a doozy. So let's take our time with it. You make party favors for an event. You tie 9 inches of ribbon around each party favor. I'm just underlining that because it's probably going to be important. Write an expression for the number of inches of ribbon needed by in party favor. So it doesn't actually tell me how many party favors I'm making. It just says in party favors, right? So up here it says there are 9 inches of ribbon for every single favor. So however many I make, it's going to take 9 inches of ribbon. So if I make only one, it would be 9 inches of ribbon. If I make 2 of them, it'd be 8 inches of ribbon. If I make 3 of them, it'd be, well, 18 inches of ribbon. If I make 3 of them, it'd be 27 inches of ribbon. And you see how it goes on and on and on. So however many favors I have, basically I just multiply that number times 9, and that equals the ribbon that I need. Right? So my handwriting is not good. Sorry about that. So basically, it doesn't tell me how many favors, but I know whatever that number is, I just multiply it by 9, and that's going to be the amount of ribbon, right? So how much ribbon do I need? 9 inches of ribbon, which 9 times however many party favors I need. All right, so that's the first part. Second part, the ribbon costs $3 for each yard. So now it's trying to trick me. You see this? Yard. It says yard now and not inches. So let's save that in our head for later. Write an expression for the total cost. So what do we want? We want cost of the ribbon in yards or in inches. Okay. So the total cost of the ribbon is $3 for every yard. I know that 1 yard equals 36 inches. So if it's $3 for every yard, well then that must mean that if I have, remember up here, this is the total amount of ribbon that I was going to buy because I had 9 times however many party favors, and it's $3 per yard. Well, then that means, remember that 9 was a number that was in inches, so that's 9 over 36. So the top part is inches, the bottom part is yards. Okay, so I put my inches in my yards, so I'm just converting here. And then in for the amount of party favors, right? So if I sort of simplify this, so basically what I'm doing here is I'm finding out how many yards I need for each party favor. So I know that I need 9 inches for every party favor, but how many yards is that for per party favor? You guys try saying per party favor like a bunch of times in a row on a video and then see how you do. Anyway, 9 over 36 is 1 over 4. It simplifies. We divide both of those by, and divide by 9 to simplify the fraction. So that's 1n over 4, or, just n over 4. So this is the number of yards in each party favor. But that's not the amount of, that's not the cost, right? Because the cost, it says, is $3 for each yard. Well, now I know that if I need $3 for every yard, and this is how many yards I have, this number here, well, then I just multiply the 3 times, however many yards I need, and that'll give me the cost. So it's 3 over 1, so that's 3/4 times n, basically, or 3n over 4 is how you could write it. I know that was complicated. If you need to kind of back it up and rewind to check it out again, to see, like, we had to come up with the number of inches for every party favor, then we had to come up with the conversion of that number to yards, which gave us that like 1/4 in, and then we had to sort of factor in the money. So it's like whatever that number was for yards times 3, because there's $3 per yard, and so that's how we wound up with this, oops, I get that big mark again. So we wound up with this 3n over 4 yards per party favor. That's an amount in dollars, right? That we would know once we actually knew the number of party favors, but we do not know the number of party favors, so we are stuck with this variable for now. So that is the end of number 8. Number 9, car A travels at 55 miles an hour, and car B travels at a greater speed of X miles an hour, Choose the expression that represents how many miles farther car B travels in 2 hours. So, let's see. Important information for this one. Car A is traveling 55 miles per hour. Car B travels at it tells us that it's a greater speed of X miles per hour. So, it doesn't tell us for sure, but we know that X is bigger than 55, whatever it is. Choose the expression that represents how many miles farther car B travels in 2 hours. Okay, so in 2 hours, so we know in 1 hour, right, this one was car A and this one was car B. We know in 1 hour car A goes 55 miles, so in 2 hours car A would go 110 miles. Car B would go 2x miles. Right, so if we want an expression that represents how much farther car A went than how much farther car B went than car A. So we know that car B went farther than car A, but the question is how much farther, right? Like if car B went 120 miles and car A went 110 miles, then, we would subtract that and 10. Car B would have gone 10 more miles. So it seems like the operation that we're looking for here is subtraction, right? To see how much farther it goes, because that's what you would do. Like if I have $130 and you have $105, then you want to see how much more you would subtract, right? So I have $25 more than you do. Hooray for me. So car B goes 2x miles and car A goes 55 times 2, which is 110 miles. So we subtract there 2x minus 110, so that would be this as the answer. Number 10, tell which property this statement 4 times, parentheses, 1 times n equals, parentheses, 4 times 1, in parentheses, times n, illustrates. So you might get tempted here because of the 1, see the 1, to say that this is the multiplication property of 1, but if you're actually paying attention, look at this, guys. It's all about these parentheses, see? Don't get fooled by the 1. Look here, what's in the parentheses? Look there, what's in parentheses. So what has happened? The stuff inside the parentheses has switched. They have reassociated. So this is not the multiplication property of 1. It is the associative property of multiplication because what is inside the parentheses has changed. It was this, and now it's this. Okay. Multiplication property of 1 would be like 4 times 1 equals 4 or something like that, like the 1 would disappear. Next, number 11, tell which property the statement 4.3 plus g equals g plus 4.3 illustrates. So this one, all that's happening is the order gets switched around. You see here the order is flipped. The 4.3 was in front, now it's in the back. So all that's happened here is these things have switched places. And remember, the word commute means switch places, right? So those numbers have commuted, so that is the commutative property of addition. Next, number 12, simplify the expression 4 plus 9 plus x. Okay, let's do it. So 4 plus 9 plus x. Well, it's telling me, PEMDAS, you remember PEMDAS? PEMDAS wants me to do 9 plus x first, but I can't actually do that. But thankfully, because of the associative property, I can rewrite this problem to be 4 plus 9 plus x. That's the associative property of addition, lets me do that. And then I can add the 4 and the 9, so that will be 13 plus x as the answer. The next one, the expression 15 times x times 6 represents the volume of a rectangular prism with the length of 15, a width of x, and a height of 6. Simplify the expression. Well, again here, so PEMDAS would want me to do this first because I'm just supposed to do it in order. But the commutative property of multiplication would let me rewrite it like this. This the commutative property of multiplication tells me that I can rearrange the factors as long as everything is just being multiplied, which it is. So now I can just do the 15 times 6, which makes 90, and then the x just comes on down. So that's 90x as the answer for this one. Simplified. Number 14. Use the addition property of 0 to rewrite this statement. So the addition property of 0 just tells me that anything plus 0 just stays the same. So I have g plus 0, so g plus 0, it just is g, right? So what I wind up with is 12 minus g. That's what the addition property of 0 would tell me. Number 15, moving right along. Use the distributive property to simplify the expression 7 times 8x plus 1. So remember the distributive property. Distributive property tells me that I should multiply the number on the outside by all the stuff on the inside. Or to help me to remember it, there's a little sound effect that I like to use, which is shoop and shoop. So the 7 shoops. Shoop. The 7 shoops. So we do 7 times 8x. So every time you shoop, you multiply. Shoop equals multiply. So 7 times 8x and 7 times 1. So that's 56x plus 7. There you go. That's the answer to that one. I distributed the 7. 7 times 8. 7 times 1. 7 times 8x anyway. Simplify the expression by combining like terms. Okay, so on this one, I have a couple of sets of like terms. So I have the 6x and the 2x that go together, and then I'll use a different color for this one. So I have the 9 and the 4 that also go together. So again, PEMDAS would tell me that I need to do the 6x and the 2x first. Well, PEMDAS would actually say that because 6x means 6 times x, so PEMDAS would tell me I need to do this first. Can't do that because I don't know what that variable is. But I can rearrange it so that all of the things that have variables and all of the things that don't have variables are next to each other. That's the commutative property of addition, again, coming to help me out to do that. And so then I have 6x plus 2x, which turns out to make 8x, okay? Now, in the background for why that works, we have the distributive property just kind of helping us out again. So, like, if you go backwards from the distributive property, like imagine the x was there and the x was there, and you could just, like, take it out, right? Like, you could unshoop it. So it would be 6 plus 2 with x on the outside, right? And then you could add the 6 and the 2 and get 8x to produce that. So 6x plus 2x winds up adding together to be 8x. And then the 9 and the 4 add together to be 13. So my answer there, 8x plus 13, when I combine the like terms. Reminder, that term like terms means it's variables that are to the same exponent and the same variable. So for example, 6x and 2x are like terms because they have the same variable and they don't have an exponent. 9 and 4 are like terms because they don't have variables at all and they don't have exponents at all. Therefore, they are alike. Number 17, write and simplify an expression that represents the sum of the perimeters of the square and the triangle. So whenever I think about perimeters, I'm always kind of thinking about like some sort of like army situation. Like I have a fortress or something inside that I'm trying to protect by making like a box or something around it, right? And that box around it is called the perimeter. Like military terminology, like you set a perimeter would mean you send soldiers out to protect a certain area, and they would kind of be along these lines here. So I always think about it as being like space around, what I'm trying to protect or something like that. But anyway, so for this square, my perimeter would be all of those sides around, which we know for a square, everything is the same length all the way around. So that's 6x, 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 and 6x. So then I would just, add those all together. My writing is a little bit too fat there, so let me erase. 6x, and there are 4 of them, so that would be 6x times 4. That would be 24x's, right? And then I have this triangle here. It's hard to see because I'm writing in a similar color to black, which is 3x plus 3x plus x minus 2. That would be the perimeter of the triangle if I added all of these pieces together. 3x and 3x together would be 6x. And then if I added the other x, that would be 7x. And then I just have my little minus 2, just kind of travels along. So I put all the x's together for the triangle, and I put all the x's together for the square, but the whole problem tells me that I need the sum of the perimeters for the square and the triangle. So I'm going to have to put my 2 perimeters together because remember, sum means addition. Okay, it means the answer to an addition problem is what it really means. So 24x plus 7x minus 2. Now, 24x and 7x are like terms, so I can put them together and make 31x. And then the minus 2 is not a like term with anything else, so it just stays the same. So I have 31x minus 2 as my final answer. I did not mean to erase that. There, 31x minus 2. Number 18, factor the expression 45x plus 20 using the GCF. I kind of already showed you this up here when I took the x out from the 6x and the 2x to make it 8x. But here I'm going to do it instead of using the variable, because you see the 45 has an x, but the 20 does not have the x. There's no x there. So I've got to find a number that they have in common so that I can factor and take it out. Factoring is the opposite of the distributive property. So 45x and 20. I'm going to see what factors they have in common. I'm going to do a factor tree to sort of see all their factors and figure out what they have in common. So 45 would be 5 times 9, and 9 is 3 times 3. 20 is 4 times 5, and 4 is 2 times 2. So I can see right away they both have this 5, right? That's the common factor that they both have. So if I'm trying to think about, if I'm trying to think about how do I go backwards from distributive property, I need some number on the outside of the parentheses that they both share. In this case, the number that they both have is the 5, so it goes on the outside of the parentheses. Now I need to think about, okay, what goes inside the parentheses. So 5 times something is going to make 45x. Well, 5 times what number makes 45? That will be 9. You see over here, 5 times 9 makes 45. But not just 9, it will be 9x, right? Because 5 times 9 gets me the 45, but I have to have the x to get 45x. Then plus, because I have a plus sign in the problem, what number, 5 times what number makes 20? Basic multiplication, 5 times 4 is the one that makes 20. So at the end, you kind of have to check and see, does 5 times 9 make 45x? Yes, it does. Does 5 times 4 make 20? Yes, it does. So 45x plus 20, boom. I just kind of checked my work and saw that I was right and that this is the correct answer for my factoring. Okay, moving on. A hairdresser receives a discount on each comb purchased. The original price of each comb is X dollars. The hairdresser purchases 12 combs for a total of this here. By how much is each comb discounted? So it tells me that she gets a discount right off the bat, and I know that that word is important. So anytime you have a word problem, you're going to try to go through the word problem and pull out, what's important? What are the words that are important? So discount I know is important. It makes me think about subtraction, because discount would be the price going down, right? So that's subtraction. It tells me that the original price of the comb, so like one comb here, is going to be X dollars. So that's useful. So if I'm buying a comb for X, but I get a discount, then that would mean
whatever I would pay originally minus something, that would be what I pay with the discount. So it says that the hairdresser purchases 12 combs for this price here. And so I just kind of got to examine this little bit here and see what I know. X, I remember, was the price of a comb. And it tells me that she buys 12 combs, so that must be where that 12 comes from, right? The minus sign there, what was that in reference to? Do you remember? It was the discount. And then how much is this person saving on combs? They must be saving this $24 right there. So on 12 combs, they save $24. So the question is, how much do they save on one comb? Well, at this point, you just have to divide 24 divided by 12, and you're saving $2 per comb. So that is the answer to that, $2 per comb. You kind of got to break it down with the word problem. Last problem. Number 20, you buy bananas and strawberries, so the ratio of 3 to 4. So that's important. So it says bananas and strawberries, so that's, if I'm making a ratio, it would be bananas first and then strawberries second. Choose the expression for the number of bananas that you buy when you buy in strawberries. So my number of strawberries is unknown, question mark. And my number of bananas is also not really known. And I kind of have to figure this out based on the information that he gives me. So if I turn this ratio into a unit rate, that would be 3/4 of a banana for 1 strawberry. So if I buy 1 strawberry, I'm buying 3/4 of a banana, which I know it would be really weird to go to the store and say, hey, can I buy 3/4 of a banana? But thankfully, this isn't real life. It's a math problem, so you don't have to be embarrassed like that. But it tells me I'm not buying 1 strawberry. I'm buying in strawberries. So whatever I started with, 1 strawberry, I'm going to be multiplying it by n to produce n strawberries. And now, since strawberries and bananas are related by this ratio, the bananas are also going to have to get multiplied times n, right? So to keep my ratio the same, if I'm getting, 12 strawberries or something, I would do 1 times 12 to make 12 strawberries. And for 3/4 of a banana, I would do 3/4 times n to tell me how many bananas I'm going to get. So that's how that would work, and that would produce this as the answer. For every strawberry that I buy, so if this number was 1, if I bought 1 strawberry, I would be buying 3/4 of a banana. If it was 2, I would be buying 6/4 of a banana. That's a banana and a half. So that is the end of the algebraic expressions little practice test here. I hope that was helpful, and I will see you next time for another video with Mr. Kraft's Math.